Okay, so we're getting ready to start Unit 7, and in Unit 7, this is proportions, and I'm going to highlight proportions because I want you to understand, like, from this point forward in Chapter 7, we are going to be setting up proportions. Now, the rules on how we set proportions depends on what kind of polygon or triangle we have, but we want to talk about, and of course, what side are we solving for. But the whole idea is that we want to set up proportions to solve for a missing unit length. And so we're going to learn how to do that in this section. So let's go ahead and go to the notes. I'm going to review what proportions are. And essentially proportions are ratios. And so if you have a word problem, the U.S. Census Bureau surveyed 8,218 schools nationally about the girls' soccer program. They found that 270,273 girls played in the 1999-2000 school year. So a proportion is a ratio, and it says players per school. So whenever we set a proportion, we typically make a fraction to describe the ratio. The thing that comes first goes on the top. The thing that comes second typically goes on the bottom. So if we have 270,273 divided by 8,213, that is equal to, well, we're going to go ahead and divide, and we want to come out with 1 on this end, okay? Because we want to know the number of players per school. When we divide, we get something close to 33, and so we're just going to put 33. So our ratio, which is really big here, gets reduced, and we can say there are 33 players per school. All right. Another way we can do it is we can compare two things, okay? And so we can write a ratio of comparing one thing to something else. And so it says 1 ounce of cheddar cheese contains 9 grams of fat. So 9 grams of fat seems to be our big thing here. 6 are saturated, and it doesn't tell us what the unsaturated are, so that's obviously not what we're doing. It says find the ratio of saturated fats to total fat. Well, let's write a proportion first. 6, so saturated was 6, and the total fat was 9. Now we've got to be able to reduce that, and again, I wanted to get 1 at the bottom, except for the fact that the bigger number's on the bottom. So I want to be able to reduce this as much as possible. 3 goes into both, so it's going to be 2 over 3. However, the key word here is ratio. So it wants to compare two things. When we have to write a ratio, we're going to write it like this. 2 to 3. Okay? So the ratio from saturated to total is 2 to 3. All right. A third way that we can look at this is we can use it to solve problems in geometry. In a triangle, the ratio of the measures of 3 sides is 4 to 6 to 9. So we have triangle 4 to 6 to 9, and its perimeter is 190 inches. Well, again, let's take the things we know. We know how to draw a triangle. And we know that the ratio is 4 to 6 to 9. Well, when you add those 3 together, because we know that perimeter means the distance around, we only get 19. So we know that we're not quite to where we need to be. So when we're trying to solve for something, we have to replace it with a variable. Okay? And so what are we going to do in order to find the length of the perimeter? Hopefully you said we're going to add the 3 pieces of information. So 4x plus 6x plus 19x, or 9x, sorry. 9x. So 4x plus 6x plus 9x. And that is going to equal 190. So we know when we add these together we get 19. So 19x is equal to 190. And so then x is equal to 10. But the question says find the length of each side. And you know, in geometry we've talked about, that's how it always works. We've got to go to that next step. So you plug the 10 back in, and of course you know you have side lengths of 40, 60, and 90. Alright. I want to talk real quickly about solving proportions when you're given the whole proportion. So if I have those four proportions, go ahead and tell me if you know how to solve them. Go ahead and pause the video and then try to solve those real quick. Okay, so hopefully you remembered from your past instruction on proportions. In order to cross multiply, you take the top left times the bottom right, and you equal that, and then you take the bottom left times the top right, and you equal that, and you end up with your answer once you use your algebra rules. Number 2, same thing, except for now to substitute, you have to distribute, and then follow your algebra rules, you get x equal to 11. Number 3 was a little bit easier, just a little bit more complicated numbers, but you follow your algebra rules, you get x equal to 20. Number 4, you had to distribute twice, you get x is equal to 11. Using word problems, you can do the same thing. Always go with what's first. Length, wingspan. So we're going to do length over wingspan. And we're going to set up a proportion. So we're going to do 78 over 90, because that's what was given to us first. And then we keep reading. A toy model is made proportionally to the real plane. Wingspan is 36. So in our second piece of this proportion, we're going to put the 36 on the bottom to match up with the original, and so then we put the x on top. So then we can go ahead and solve. 36 times 78 divided by 90, we get x is equal to 31.2 centimeters. Okay, at this point we are done with the first section, so I want to go and talk about the work that's to be done. On page 183 in the workbook, it says to do 1 through 18, so I'm going to go ahead and talk about that with you guys real quick. Yep. So on page 183 it says to do 1 through 18. Now 1 through 18 is just working on the same things we've been talking about. If a salad plate is 8 inches and a dinner plate is 1 foot, well, 1 foot is 12 inches. What's the ratio? Well, it's 8 to 12. Can that be reduced? It can. Hopefully you'll be able to find the answer. A couple things that you're going to have to know again is 12 inches in a foot. So you're going to have to do some calculation. The other thing you're going to have to know is there are 16 ounces in a pound. So for 1 through 5, you need to reduce the ratios. It's just practice like example 2 in our notes. So 1 through 5 is just like example 2 in our notes. So if you're doing these, you need to go back and look at example 2 in your notes and on the video. 6 through 8, these are just like example 3 in our notes. Set up a picture, write up a problem, and then solve for the variable, and then find the missing piece. And then finally 9 through 18 are just simple reviews over how we write a proportion as we move forward. Okay, so at this point you're going to pause the video, you're going to complete 1 through 18. When you're done with 1 through 18, you can move on to the second part of the notes, and you can give me a check off if you want to before. But like I said, go ahead and pause the video, complete 1 through 18, and then we'll keep going on the similar polygon stuff. Okay. When polygons have the same angles, but they may be different in size, they are called similar polygons. And here's the symbol. Okay, so again, it's the congruency marker without the equal part, because they're not equal, they're similar. Two polygons are similar if the corresponding angles are congruent. But here's the important thing, and this is why we've been doing this section. The corresponding sides have to be proportional. So we look at these two sets and we try to decide if the pair of figures are similar. So the first thing we have to ask ourselves, do all the angles match up? Well, number one, obviously, there's a big problem here. This one has a right angle, this one doesn't. So these are not similar because the angles don't match up. So then we go to number two. And we have to decide whether or not every pair of figures is similar. Well, look at the angles, 37, 27, but we don't know what this one is. Well, some quick math, 180 minus 37 minus 27 tells us this angle is 116. So then I bet this angle is 27. Do the angles match up? Yes. So now we have to decide if they are proportional. Between 37 and 116, there is a side of length 5x. Over here, it's a length of 4x. So our ratio from left to right is 5 to 4. Well, the other ones also have to match. So between a 37 and a 27, we have a 10. On this side, we have an 8. Does that also match the 5 to 4 ratio? Yes. Between the 116 and 27, we have a 15. Between 116 and 27, we have a 12. Does that also match the 5 to 4 ratio? And the answer is yes. So these two are similar because the angles are congruent and the sides have a ratio of 5 to 4. We also call this right here the scale factor. And so if we were using a polygon above with the same scale of 5 to 4, from left to right, we would call it 5 to 4. What do you think we'd call it from right to left? Well, we would call it 4 to 5. You can go either way, but you have to pay attention to the question that you're being asked. If I'm telling you to go from left to right, you use 5 to 4, or whatever the ratio is. If I'm telling you to go from right to left, then you have to go 4 to 5, or whatever the ratio is. Okay? So, if we have similar polygons, we can also figure stuff out. We can solve for missing pieces. But we have to have a base ratio in order to do that. Okay? So, here it says the two polygons are similar. Solve for x and y. Well, let's find a base ratio to go off of. Here's an 8 that's labeled next to the one angle and what we assume is the right angle. We don't know for sure. On this shape, it's 12. So we found our base ratio. Our base ratio is 8 to 12. So the question is, how do we solve for x? Well, in order to solve for x, we have to find the corresponding part on the other triangle. So see how 8 is adjacent to x? 12 is adjacent to 9. So we go ahead and put that in the other spot. So 8 over 12 is equal to x over 9. Like now we're at the proportion part we just got done. So we cross multiply and we solve. X is equal to 6. Go ahead and solve the other three problems here on this part. Again, you have a base ratio for y on the top. You're going to have to find a new base ratio to solve for x and y in these last two. But go ahead and solve these last three. Pause the video. When you're done, I'll have the answers. Okay, for this one, you had to do 8 over 12 and 10 over y. When we cross multiply and solve, y is 15. For this one, our base ratio is 10 over 5. Again, notice the 1 and the 3, or the 4, the 1 and the 4, 10 over 5. So to solve for x, we have to do 10 over 5 equals 4.5 over x. So for x, we get 2.25. For y, we had to do 10 over 5 is equal to y over 2.5. So for y, we got 5. Sometimes you're given the scale factor and you're asked to solve for a missing piece. So here, we're told the scale factor is 2 to 3. So to solve for the missing piece, we're just going to do 2 over 3. And then we have to go ABC to x, y, z. So we've got to be careful. AB is to x, y. 6 over r. 2 over 3, BC is to YZ, so we've got 8 over T. And then finally, 2 over 3, 10 over S. Make sure that's important. ABC was turned from XYZ, so you couldn't just do 6 over R, 8 over S, 10 over T. It's not the way it worked. So anyway, when we're all said and done, R is 9, T is 12, and S is 15. All right, so now we're going to check the workbook here, and it says page 187, 4 through 10, 19 through 24. And again, it's just working on, are these things similar? If the angles match up and the sides are proportional, then they are similar. So in 4 through 10, that's all you're checking for. Do the angles match up and are the sides proportional? On 19 through 24, I give you two triangles. And this is just what we just practiced. What's the scale factor? So find the two sides that match up between these two triangles. And then also fill in the angles that's missing on each one. And then once you know the scale factor, you can also tell me the length of these two sides. Okay? So go ahead and do these and check them. And when you are done, you are good to go to move on to Unit 2.